Hello students, welcome to the lecture on chemical reaction, and after this lecture we will be able to learn the following objective. Explain the chemical reaction, understand the writing chemical equation, describe the balancing chemical equation, explain the types of chemical reaction, describe the reaction in aqueous solution, explain the Ionic equation, define the reaction rate and equilibrium. Let's start with some basic definition. A chemical reaction equation is a symbolic notation system for describing chemical changes. Reactants are the substances that are present before the chemical change. These are written on the left side of the reaction equation. The products are the substances that are present after the chemical change. These are written on the right side of the reaction equation. An arrow separates the reactants and the products. Equilibrium is a chemical reaction in which the reactants are converted into products at the same time and rate that the products are converted into reactants. The reaction arrow for an equilibrium looks like right and left pointing arrows written one on top of the other. Coefficients are the relative number of moles of each of the reactants and products. These numbers are written in front of the chemical formulas. Now let us discuss the concept of chemical reaction in detail. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as products. Chemical reaction must be distinguished from physical changes. Physical changes include changes of state such as ice melting to water and water evaporating to vapor. If a physical change occurs, the physical properties of a substance will change, but its chemical identity will remain the same. When water is electrolyzed, we can write that H2O becomes H2 and O2. The reaction itself is the formation of two colorless gases, hydrogen and oxygen, when an electric current is passed through the colorless transparent liquid water. It is important that you realize the distinctions between reactions and equations. Chemical reactions may be elementary reactions or stepwise reaction. Chemical reaction is a process in which one or more pure substances are converted into one or more different pure substances. For example, nitric acid, which is used to make fertilizer and explosive, is formed in the chemical reaction of the gases ammonia and oxygen. A chemical equation is a shorthand that scientists use to describe a chemical reaction. Chemical equation for a chemical reaction is written as Step 1. Identify the reactants and the products of the chemical reaction. Step 2. Write down the formula or symbols of the reactants only the left hand side with a sign of plus. Between them, the formula or symbols of the products forming the reactions are written on the right hand side with a sign of plus them. Such a chemical equation is called the skeleton equation. Step 3. Count the number of atoms of each element on both the sides. If the number of atoms of each element only both sides is equal, then the equation is called a balanced chemical equation. If the number of atoms of any one or more of the elements on both the sides is not equal, then these are made equal by adjusting the coefficients before the symbols and the formula of the reactants and products. The process by which the number of atoms of each element on both sides is made equal is called balancing of chemical equation. Step 4. In the end, the chemical equation is made molecular if required. Balancing a chemical equation refers to establishing the mathematical relationship between the quantity of reactants and products. The quantities are expressed as grams or moles. There are essentially 3 steps to the process. Chemical formulas of reactants are listed on the left hand side of the equation. Products are listed on the right hand side of the equation. Reactants and products are separated by putting an arrow between them to show the direction of the reactions. Reactions at equilibrium will have arrows facing both directions. Balance the equation. Apply the law of conservation of mass to get the same number of atoms of every element on each side of the equation. Once one element is balanced, proceed to balance another and another until all elements are balanced. Balance chemicals formulas by placing coefficients in front of them. Indicate the states of matter of the reactants and products. Use G for gaseous substances, use S for solids, use L for liquids, use Ag for species in solution in water. Write the state of matter immediately following the formula of the substance it describes. Steps of balancing a chemical equation. Identifying each element found in the equation, the number of atoms of each type of atoms must be the same on each side of the equation once it has been balanced. What is the net charge on each side of the equation? The net charge must be the same on each side of the equation once it has been balanced. If possible, start with an element found in one compound on each side of the equation. Change the coefficient so that the number of atoms of the element is the same on each side of the equation. Remember, to balance an equation, we change the coefficient, not the subscript in the formulas. Once we have balanced one element, do the same thing with another element. Proceed until all elements have been balanced. Check the work to make certain the charge on both sides of the equation is also balanced. Let us see an example. Fe plus O2 gives Fe2O3. If the number of atoms of each element in the equation above is counted, it is observed that there is one atom of Fe and two atoms of O on the left side and two atoms of Fe and three atoms of O on the right. Left side, one atom Fe, two atoms O. Right side, two atoms Fe, three atoms O. The balancing of the equation is accomplished by introducing the proper number or coefficient before each formula. To balance the number of O atoms, write a 3 in front of the O2 and a 2 in front of the Fe2O3. Fe plus 3O2 gives a 2Fe2O3. The equation now has 6 atoms of O on each side, but the Fe atoms are not balanced. So there is one atom of Fe on the left and 4 atoms of Fe on the right. The Fe atoms can be balanced by writing a 4 in front of the Fe. 4 Fe plus 3 O2 gives a 2 Fe2O3. This equation is now balanced. It contains 4 atoms of Fe and 6 atoms of O on each side of the equation. The equation is interpreted to mean that 4 atoms of Fe will react with 3 molecules of O2 to form 2 molecules of Fe2O3. Now moving on to the next topic, chemical reaction. Chemical reactions tend to involve the motion of electrons leading to the formation and breaking of chemical bonds. There are several different types of chemical reactions. Here are some common types of reactions. Direct union or combination reaction, decomposition reaction, displacement reaction, metathesis or double displacement reaction, combustion reaction, oxidation reduction reaction, isomerization, hydrolysis reaction. We will discuss them one by one. Direct union or combination reactions. Any reaction in which 2 or more substances combine to form a single product is a direct union or combination reaction. The general form of a direct union reaction is A plus B is raised to AB. This type of reaction generally takes place between the following types of compounds: A metal plus non-metal, metal oxide plus non-metal oxide, non-metal oxide plus non-metal. Decomposition reaction. A decomposition reaction is one in which a single reactant breaks apart into more than one product. Decomposition reactions are the reverse of combination reaction. A single reactant is broken down into 2 or more products, either elements or compounds. A decomposition reaction will take place because the compound is unstable or as a result of heating or electrical decomposition, electrolysis. The general form for a decomposition reaction is AB breaks into A plus B. Some example of decomposition reaction are as shown. Displacement reaction. A displacement reaction, sometimes called oxidation reduction equation, involves an element reacting with a compound whereby the element displaces a second element from the compound. The general form of this type reaction is A plus BC raised to AC plus B. Displacement reaction usually occurs between the following combination: an active metal plus an acid. When a metal which is above hydrogen in the activity series is reacted with an acid, hydrogen is liberated and a salt is formed. Metal plus salt. Each metal in the activity series displaces any metals below it to form a salt in solution. A halogen FClBrLAT will displace any less active halogen from a halide salt. Metathesis or double displacement reaction. A metathesis is a double displacement reaction that usually occurs in water solution. The general form of metathesis reaction is AB plus CD raised to AD plus CB. The principal condition that favor the completion of these reactions are formation of an insoluble compound, a precipitate, formation of a gas, formation of water. Metathesis reactions are generally classified as precipitation reaction or as neutralization reaction. Precipitation reaction. In this type of reaction, two compounds which are water soluble react to form two new compounds, one of which is a precipitate that is insoluble in water. The precipitate is often indicated by an arrow pointing downward written next to its formula. Neutralization reaction. A neutralization reaction, sometimes called acid-base reaction, occurs between an acidic compound and a basic compound to form a chemical salt and water. Reaction between an acid and a base is as shown. Combustion reaction. Combustion reaction generally apply to organic compounds such as hydrocarbons, which are used as fuels. In these cases, the compound is being burnt in air or oxygen and producing carbon dioxide and water as products. A general form for a combustion reaction is as shown. Some examples of combustion reaction are shown on the screen. Oxidation, reduction or redox reaction. In a redox reaction, the oxidation numbers of atoms are changed. Redox reaction may involve the transfer of electrons between chemical species. This is an example of a redox reaction. Isomerization. In an isomerization reaction, the structural arrangement of a compound is changed, but its net atomic composition remains the same. Hydrolysis reaction. A hydrolysis reaction involves water. The general form for a hydrolysis reaction is shown here. Now let us discuss the reactants and products of a chemical equation. The reactants are the substances that are present before the chemical change takes place. They are the things that are present at the starting point. By convention, the chemical symbols for the reactants are written on the left-hand side of the chemical reaction equation. The products are the substances that are formed during the chemical change. They are the things that are present at the end. By convention, the chemical symbols for the products are written on the right-hand side of the chemical reaction equation. A reaction arrow is a symbol that signifies the actual change. A reaction arrow separates the reactants from the products, while a typical chemical reaction equation will include much more information. They all have the substances present before and after the chemical change with a reaction arrow to separate them. A double arrow signals that the reaction is equilibrium, a situation in which the reactants are changing into products at the same time as the products are changing back into reactants. In a chemical reaction, substances, elements and/or compounds called reactants are changed into other substances, compounds and/or elements called products. We cannot change one element into another in a chemical reaction. That happens in nuclear reaction. Instead, we create a new substance with chemical reactions. A number of clues show that a chemical reaction has taken place. For example, something new is visibly produced. A gas is created. Heat is given off or taken in. A chemical reaction follows the format as seen here. For example, methane, natural gas, reacts with the oxygen in the atmosphere to produce carbon dioxide and water vapor. The chemical equation that represents this reaction is written like this. Methane and oxygen. Oxygen is a diatomic two-atom element are reactants, while carbon dioxide and water are the products. All the reactants and products are gases indicated by the G is in parenthesis. In this reaction, all reactants and products are invisible. The heat being evolved is a clue that tells us a reaction is taking place. This is a good example of an exothermic reaction, a reaction in which heat is given off. A lot of reactions are exothermic. Some reactions, however, absorb energy rather than release it. These reactions are called endothermic reactions. We have to supply a little energy to get a reaction going. The energy we have to supply to get a reaction going is called the activation energy of the reaction. A chemical equation uses chemical symbols for reactants and products to describe a chemical change. Water is by far the most common medium in which chemical reactions occur naturally. It is not hard to see this. 70% of our body mass is water and about 70% of the surface of the earth is covered in water. The types of reaction in aqueous water medium that will be studied are as follows: precipitation reaction, acid-base reaction, oxidation reduction reaction. A solution is a homogeneous uniform mixture. A solution consists of two generic components: solute, the component or compound that is in minor quantities, and solvent, the component that is in major quantity. Aqueous solutions then have water as a solvent. Precipitation reaction. Precipitation reaction are those reactions in which two aqueous solutions, when mixed, react to form a solid. The solid thus formed is known as a precipitate. Thus, a precipitate is an insoluble solid. When an ionic substance is dissolved in water, we indicate this by appending an AQ after the formula of the compound. Thus, for example, NaCl designates an aqueous solution of sodium chloride. Acid-base reaction. Acid-base reaction, a type of chemical process typified by the exchange of one or more hydrogen ions H+ between species that may be neutral or electrically charged. It also includes analogous behavior of molecules and ions that are acidic but do not zonate hydrogen ions. Acids are chemical compounds that show in water solution a sharp taste, a corrosive action on metals, and the ability to turn certain blue vegetable dyes red. Bases are chemical compounds that in solution are soapy, the touch, and turn red vegetable dyes blue. When mixed, acids and bases neutralize one another and produce salt. Substances with a salty taste and none of the characteristic properties of either acids or bases. Acid and base properties. Substances have long been classified as acid or bases according to some generic properties which are summarized. Their reactions with each other produce salts. Acid properties: when dissolved in water, acids conduct electricity, change blue litmus to red, have a sour taste, react with bases to neutralize their properties, react with active metals to liberate hydrogen. Base properties: when dissolved in water, bases conduct electricity, change red litmus to blue, have a slippery feeling, react with acids to neutralize their properties. Oxidation reduction reaction. Redox reaction or oxidation reduction reactions have a number of similarities to acid-base reactants. Fundamentally, redox reactions are a family of reactions that are concerned with the transfer of electrons between species. Let us study the concept of ionic equation now. An ionic equation is a chemical equation where the electrolytes in aqueous solution are written as dissociated ions. An ionic equation is able to show the physical states of all the reactants and products unambiguously by including any dissolved ionic species as ion. The same rules apply as for formula equation in that all species shown on the left must also be present on the right hand side of the equation. In addition, notice that the electrical charge present on both sides of the equation must also balance. Thus, the equation for another ionic solid, barium chloride, dissolving in water would be as seen here. Now coming over to the last topic of our lesson, rate of reaction. The reaction rate is a measure of the change in the concentration of reactants or products over time in a chemical reaction. There are four basic factors that can affect the rate of a chemical reaction: temperature, concentration and pressure, physical state, catalyst. Let's talk about each now. Temperature. Temperature and rate at S level is connected very closely with the Maxwell-Boltzmann distribution. An increase or decrease on temperature will change the shape of the curve, which means fewer or more particles will have the required activation energy. Concentration and pressure. If the concentration or pressure of a chemical increases, there will be more particles within a given space. Particles will therefore collide more often. As concentration or pressure increases, the rate of reaction also increases. Physical state. If particles are in the same phase, liquid or gas, then it is very easy for them to mix with each other. This gives particles a maximum opportunity to collide. But if one of the reactant is a solid, then the reaction can only take place on the surface of the solid. The smaller the size of the solid particles, the greater the area that the reactions can take place in. Catalyst. A catalyst is a substance that alters the rate of a chemical reaction without being used up or permanently changed chemically.
0.1 mole each of carbon monoxide and nitrogen dioxide are taken in a 1-litered round-bottom flask, and the flask is stoppered. Observe the color of this gaseous mixture in the flask. Now place the flask in an oil bath heated to 500 Kelvin. Observe the change in color of the gaseous mixture after every 2 minutes. Initially, when the gaseous mixture was at room temperature, it was dark brown in color. But when the flask is kept in an oil bath and heated, gradually the brown color fades. Why is this so? What happened when this gaseous mixture was heated? The carbon monoxide gas reacted with nitrogen dioxide, a brown-colored gas. Carbon dioxide and nitric oxide, that are both colorless gases, are formed by this reaction. That is, carbon monoxide and nitrogen dioxide are consumed. At the same time, carbon dioxide and nitric oxide are formed.
Now in the end, let us summarize what we have learned in this lecture. A chemical reaction equation is a symbolic notation system for describing chemical changes. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as products. Balancing a chemical equation refers to establishing the mathematical relationship between the quantity of reactants and products. A decomposition reaction is one in which a single reactant breaks apart into more than one product. The reactants are the substances that are present before chemical change takes place. The products are the substances that are formed during the chemical change. A solution is a homogeneous uniform mixture. The reaction rate is a measure of the change in the concentration of reactants or products over time in a chemical reaction.